Hi everyone, in this lecture we will update Elastic Query Service to query analytics data from Kafka Stream Service. First of all, we need to add OAuth2 client dependency to Elastic Query Service, next to OAuth2 server dependency. So this service is both a resource server and also a client at the same time. Then add OAuth2 client properties in the application config and set the client ID and secret for the Elastic Query Service. We already created this client in Keycloak console when we were configuring Keycloak. The important difference here is that we use client credentials for the authorization type instead of authorization code flow. Remember that client credentials is used for machine-to-machine communication when there is no user interaction required. And our case is exactly that, because we want to call Kafka Stream Service and get aggregated word count result from query service without user interaction. So we just need this client ID and the client secret in client credentials flow. Of course, we also set the token URI of Keycloak to be able to obtain access token here. Second thing that will change in config is that we will add a web client definition, as was in our web client service. We will have an additional query type property here and set it to Kafka state store, and also specify the method, URI, and accept type of the Kafka Streams API. We do this because in the next section we will add another query type to query from analytics database and make this choice in the config. Stay tuned for that. For the HTTP method, we set get and set the URL of the Kafka Streams API endpoint to get the word count. Let's also update the config data for query service and add this web client properties there. We set the query type and use the inner class query to set the method, URI, and accept type. Then we need a web client config for the query service. Let's add this class. We need web flux dependency first. Remember that in web client application we have used OAuth2 configuration to add the access token directly to each HTTP request. This time I want to show an alternative way where we can manually set the bearer token. So I won't set the OAuth2 configuration in web client. We will pass the access token in the request itself. So here in the web client config implementation of Elastic Query Service, we will first inject config data web client object, which will provide us the required config variables to construct the web client. We will then create a web client builder method with bean and load balanced annotations. Actually, this is very similar to the web client configuration on the web client microservice. We had an additional private getTCP client method to customize the TCP client timeout values. Let's use the same approach. So I will copy these methods and use them. Only difference is that we will not use OAuth2 configuration in the web client as I just mentioned. Again, the reason of this is to show an alternative way of using access token by setting it in the header manually on each request, instead of configuring it in the web client. So when we use the web client builder in our code shortly, we will be setting the OAuth2 access token into the request directly. Stay tuned for that. Note that we didn't set the base URL in web client config because we will use the same web client for both Kafka Streams API and also for the Analytics Service API that we will develop in the next section. Now we will create a new model called Elastic Query Service Analytics Response Model that will include a list of response models as well as a long value for word count. And in Elastic Query Service interface, we will return this object. Then let's change the implementation of getDocumentByText method. We will obtain the list of response models and assign to a variable and then return a new model we created, which is Elastic Query Service Analytics Response Model, by building it with the response model list and also with a method to return the word count. Let's create a method called getWordCount and pass the text and also the access token. At this point, we will create an enum type for query type with two values, Kafka State Store and Analytics Database. We will use a string property and specify it in the enum constructor. Then in the Twitter Elastic Query Service implementation class, inject the Elastic Query Service config data, and in the getWordCount method, check first the query type from the config data, and if it's a Kafka State Store, we call another method, getWordCount from Kafka State Store. This one will extract the query properties from config and then retrieve the response model. I will create another method here to create the Spring Web Client and retrieve the response. At this point, we will inject the web client using the qualifier annotation we set on the web client configuration. and then use Web Client Builder to set HTTP methods, set the base URI, and also the path variable using the URI builder methods, and then set the bearer token as header by using the headers methods, as you can see here. So that way we are sending the access token in the request as part of the HTTP headers. Then we set accept type and then retrieve the result to map to Elastic Query Service Analytics Response Model. Also, let's enable logging for this builder and then call the block method as we want to get the data synchronously here. We also specify different onStatus methods for authentication errors, client errors, and server errors, and create an exception class instance accordingly in case there is an error. As you can see, this call is similar to the one we used in the web client application. However, we added a bearer token manually. Here we used Analytics Response Model directly as a response model for Kafka Streams API, where Kafka Streams API returns word and word count. And in the Analytics Response Model we have word count fields, so it will work to obtain the word count. However, I would like to create another response model here, specific to Kafka Streams API, with fields word and word count instead. Let's create the class named Elastic Query Service Word Count Response Model and then use it here. This way we will be safer, as we do not create a dependency to Analytics Response Model in case we want to change it later. And also we can use this new model for the analytics service that we will create in the next lecture, as it will return the same result, as we will see. So here I am changing the returned response model to the new response model we created. Alright, we now configured Elastic Query Service. Now we can change the controller. In getDocumentByText method, I will now inject two new objects. First, Twitter query user with the authentication principal annotation. This one we will use for principal and just for login purposes to log the username. The second one, which is annotated with registered OAuth to authorized client and with parameter keycloak, that will provide us the access token by using getAccessToken and getTokenValue methods, so we can pass this to the service layer. And then we change the return type to Elastic Query Service Analytics Response Model and return this object from this endpoint. We will also change the permission evaluator class and change the response type to new analytics model, as we were previously parsing the response to a list of response model. Great, now we need to adjust the web client service to accept this new object. So let's open the web client common module and add a new model, Elastic Query Web Client Analytics Response Model. Then open the Elastic Query Web Client module and change the service interface and implementation to accept the new model we created. Again, I won't use the same model for query service and query client, and instead repeat the model definitions, because creating a dependency to the same model from two different services will not be a good idea and can cause trouble later when we want to change one of the services independently. We will also change the web client controller and assign the service layer result to analytics response model, and then extract the list of response models from this object to send to the timeLF template. We then set the word count to the template by getting it from the new response model and set a property word count into the timeLF. We can change the home timeLF template now and include this word count in the response. That's great, now it's time to run everything together. I will first commit and push config server changes, and then run maven install command to create the Docker image for the new Kafka Streams service. Then adjust the environment variables to set host names instead of localhost for keycloak, Kafka and config server in Kafka Streams service environment variables. For port, we give the next available port, 8187. Here we use the same entry point for Kafka Streams as was in the query service or web client. We also need to change query service config to set the correct host name for the new Kafka Streams endpoint, and also for the OAuth to client provider keycloak token URI. Finally, Twitter to Kafka service, which is responsible to create Kafka topics, needs to be updated to create the new topic. So let's add the new topic name Twitter Analytics topic to the topic names to be created. Also update the Twitter to Kafka service to add a volume map for keycloak check file, as this service depends on config server, and in config server check file we refer to keycloak check file. Now if we run docker compose up command and open the web client on browser, when we search for a text we should be able to search word count on the results. And here we go, we have aggregated result from Kafka Streams service. Note that while Elasticsearch has all historical data, Word count here is calculated after we run application using Docker Compose app command. So it is the word count of latest run, not the whole historical data. Congratulations, we finalized another section successfully. I will see you in the next section where we will dig into the Spring Data JPA and create an analytics service to feed a Postgres database.